Let's make few observations that's going to help us with a lot of numericals and derivation. So first thing is nature of values in each quadrant. In first quadrant, the value of x and y, how does it look? Yes, both are positive. Second quadrant, first thing is, let me talk about quadrant. So we have this to be the first, second, third and fourth. Second quadrant is left and up, so this are negative and positive. When we talk about third quadrant, it is left and bottom, so negative and negative. Fourth is right and bottom, so right is positive, bottom is negative. Now, using this particular knowledge, can we derive the nature of trigonometric ratios in each quadrant? We can. It's same as this actually. So cos is related to x and sine is related to y. So we have positive and positive, negative and positive, negative and negative, positive and negative. With this information, can we derive tan theta? Think about it. We can, right? So tan theta is what? Tan theta is nothing but your sine theta by cos theta. So basically we need to divide. Positive divided by positive is positive, negative divided by positive is negative, negative negative is positive, positive negative is, yes, negative. Now let's summarize this. In what ways? Well, there's something called as all student take coffee. A stands for all, which means all the trigonometric ratios are positive here. S stands for sine, so sine and the inverse of that, that is cosec, are positive in second quadrant. Can you look at this? Right, while cos and tan are negative, and so sec and cot will be negative as well in second quadrant. Third quadrant, T stands for, yes, tan and cot are positive in our third quadrant, right? Third quadrant, tan is positive. And in fourth quadrant, what is positive? Yes, cos and sec is positive. Okay, so this is something that you guys have to know. So this is nothing but all student take coffee. That's how you can remember. Okay, now second set of observation, odd and even multiples of 9. So before I talk about odd and even multiple of 9, first thing is I want to talk about how do we represent odd numbers, odd integers. 2n plus 1, where n belongs to z, right? Set of integers, is it not? So basically anything over here like 1 2 3 4 5 6 or minus 1 0, whatever we want, when we put it over here, what happens? 2 into whatever the number is, it makes it an even number. When I add 1 to it, it makes it an odd number, right? This expression represents all the odd numbers that we can think of, while an even number is represented with 2 into n. So all the even numbers can be obtained with 2 into n. Okay, agree? Right? And one more thing that we'll need to recall is the following. Cos of 90 minus theta is sine theta, while sine of 90 minus theta is, yes, cos of theta. Okay, so let me kind of make this observation. All student take coffee. So this is your first quadrant, second, third and fourth. Okay, now 90 minus theta, in which region will the 90 minus theta angles come? Yes, in the first quadrant. In the first quadrant we have 90 minus theta, right? And this also 90 minus theta comes in the first quadrant. Why is this important? You will understand in time. So this is an observation that we kind of have to make. Now, so let's start off with what exactly we are trying to understand. Till now we were just talking about odd and even number and something that we have studied from the past. Okay, so a bit of recall, and now we'll start off with the cases. Case when the numbers are odd, right? So what is that we are looking at? So we are looking at cos of 90 plus or minus theta will be equal to plus or minus sin theta. So if you go back to the previous set of videos, whenever we saw it's actually incomplete, odd multiple of 90 plus or minus theta, we saw it turned out to be that we have to take up the complementary trigonometric ratios of cos. So cos ka complementary is sine, right? So if I take up any angle with an odd multiple of 90, always I have to figure out its sine ka value, for example. And one more thing over here, one more observation that we have to make, this negative or positive, it depends on the quadrant. Okay, so let me make this point. This thing depends on quadrant. So what is this? How is this? I'll give an example, it will be clear. So don't think too much, I'm giving an example. Now, example being this, cos of 1 into 90 plus 30. Okay, this is nothing but sine of 30. Because it's an odd multiple of 90, I have to take sine ka value of 30. It's equivalent to this. This derivation we have done. Now, along with this, I need to decide on the positive and negative nature of the value. Since we are talking about cos ka function, it will be negative in which quadrant? In first quadrant. See, 1 into 90 plus theta is in which quadrant? Answer that question first. 1 into 90 is 90 plus theta means it's in second quadrant. In second quadrant, cos ka value is negative. And so cos of 1 into 90 plus 30 is minus sine 30. Okay? Agree? While cos of 3 into 90 plus 30, first thing, how to do this? I'll teach you guys a sequence of thinking. First thing, since it's an odd multiple of 90, so we have to take up this sine because cos ka complementary trigonometric ratio is sine and the angle is 30 over here, and then look into the quadrant. So 3 into 90 is on the negative y-axis, plus 30 means fourth quadrant. In fourth quadrant, cos is positive, so this will be positive. Okay, so this is in second quadrant, this is in third quadrant. And so we saw that this particular value depends on the quadrant. So think logically. So this is fourth quadrant, not third, fourth quadrant. Think logically, right? From the derivation and everything. And also in fourth quadrant, cos values are positive because, well, x-axis are positive and in first and fourth quadrant, right? So with all of this logic, you should be able to understand all of this. It's very simple. Okay. So same set of understanding or thinking goes over the sine as well. Sine of odd multiple of 90 plus or minus theta will be equal to plus or minus, what should it be? Yes, cos of theta. Okay. So here too, everything depends on the quadrant. For example, what is this? Sine of 1 into 90 plus 30 will be what? First thing is it's an odd multiple, so I have to take up cos, right? And theta over is 30. 1 into 90 is we are on the positive y-axis, plus 30 is we are in second quadrant. In second quadrant, sine is positive. So we are in second quadrant, so sine is positive. Agree? Now, sine of 3 into 90 plus 30. So again, first is we are looking at 3 odd multiple of 90. So cos will turn out to be, sine will turn out to be cos, and the angle is 30. Now, 3 into 90 plus 30 is which quadrant? Fourth quadrant. In fourth quadrant, what are we looking at? Yes, this is negative, right? What is negative? Sine is negative. Okay, we have to take up the sine's nature of value. So sine is negative, so it has to be minus cos of 30. Right, guys? So again, all we have to do is think in a systematic way. The order of thinking, it can vary. It's not that you have to follow a particular order. But yeah, one particular order, whatever is in your head, you have to follow that. Okay. So yeah. Next, this was your case for odd multiple. Next is your even multiple. So case when we have even multiple of 90. So for example, cos of even multiple of 90 plus or minus theta is equal to plus or minus cos of theta. That is, the cos will remain cos and will remain tan, sine will remain to be sine, right? So let me give an example. Cos of 2 into 90 plus 60 is equal to, since it's even multiple, cos will remain cos, 60 is the angle, 2 into 90 plus 60 is which quadrant? 2 into 90 is negative x-axis plus 60 is in third quadrant. Third quadrant, it is negative. Is it not? Right? Now, let me go with one more example. Cos of 2 into 90, or let me do this. 4 into 90. Till now I've been talking about plus. Even with minus, it's the same stuff. So cos of 4 into 90 minus 60. Since it's 4, right, it's an even number. So angle is 60, right? So since it's an even number, cos will remain cos. Angle is 60. Now, which quadrant are we talking about? 4 into 90 is nothing but your positive x-axis. Minus 60 is your fourth quadrant. In fourth quadrant, cos is positive. So this will be positive. Okay. Again, this can be 30 and so this will be 30. Right guys, agree? Now, one more example, cos of, it's nothing much actually. 2 into, it doesn't make, okay, and let me do this. 2 into 90 minus 45. Just one more example, no issues. So this is an even number, so cos will remain cos, the angle is 45. Now, 2 into 90 is negative x-axis, minus 45 is second quadrant. So in second quadrant, this is negative, right? So this, when you talk about quadrant, so this was third, this was fourth, and this was second, right? So I can give such examples over here also. I didn't give negative wala. Let me give negative wala. Sine of, let me do this, negative, okay, 3 into 90 minus 45, right? Since it's 3, this will be cos, angle is 45. And which quadrant are we talking about? 3 into 90 is your negative y-axis, minus 45 is your third quadrant, right? Remember, if you guys are not able to understand, this is 1 into 90, this is 2 into 90, this is 3 into 90, and this is 4 into 90, right? Okay, complete rotation or revolution. So this is 3, so 3 into 90 is over here, minus 45 is third quadrant. So this will be what? This will be negative. So this is third quadrant and this is negative. So I think this example will set your thinking straight. Okay, I think, okay, this is good enough. I just needed space over here. Cos of 3 into 90 minus 45 or minus 20 also. It doesn't matter, but anyways, we don't know. Okay, let's not think about it. Now let's do it. 3. So it's an odd multiple of 90. So this will be sine. Angle is 20. 3 into 90, where is that? We are on negative y-axis. Minus 20 is second quadrant, right? Sorry, not second quadrant, third quadrant. So third quadrant, this will be negative. Okay, so 3 into 90 plus 30 ended up being positive, while 3 into 90 plus 20 or 30, whatever, it won't matter. The nature of the value will be negative. Right? This is how you should think. Okay, guys. Very simple, is it not? Don't worry, there is a set of tricks that we can use to make it simple. When I'm doing numericals, I'll teach you guys that. Now, coming back to your case for sine. Sine of even multiple of 90 plus or minus theta is equal to plus or minus sine theta. Right? So, for example, we have sine of 2 into 90 plus 60. Okay, so we are talking about which quadrant? 2 into 90 is your, yes, your negative x-axis, plus 60 is your third quadrant. So third quadrant sine is negative. Since it's 2, so this will be sine itself and the angle is 60. So we're talking about which quadrant? Over here, we're talking about third quadrant. Okay, next we have sine of 2 into 90 minus 60, for example. So first thing is 2 into 90 plus minus 60 is 2 into 90 is negative x-axis, minus 60 is your second quadrant. So this is positive. So sine will remain sine because it's an even multiple, and this is 60. So this is second quadrant, right? Look at the variation. Okay, so I'm hopeful and I'm confident that I've summarized all the requirements and you have understood. Okay, yes. Now with all of this understanding, again a very important conclusion about negative angles. Okay, for example, if I'm measuring this angle, it's minus theta. Minus theta. So this is parallel to y-axis. And this is positive theta. Okay. So this is 90, 90. So what is that I am trying to do? I am trying to make you guys understand the relationship between minus theta and positive theta in terms of your sine and cos. Okay. So with this, you'll also be able to understand your tan as well. So this point, say I'll take it as Q, and this is A comma B, while this is P, M comma N. So as usual, we know that this is cos of theta and this is sine of theta. And since this is negative angle, this is cos of minus theta and sine of minus theta. Okay. Now, the conclusion that we can come to as per similarity of triangles, as the triangles are congruent, right? These two triangles are congruent, not similar, congruent. The lengths will be equal, one thing, right? A, right, along the x-axis, that is A, will be equal to M in terms of magnitude. In terms of height, B will be equal to, this is N. But when it comes to in terms of coordinate, right? So this is in terms of coordinate. What can we tell? Think about it. A and M are one and the same. So there's no debate about this. While the height B will be negative of N, or negative B is equal to N. Okay. So what is the important conclusion over here? The conclusion being the following. A is nothing but your A is cos theta is equal to cos of minus theta. So therefore cos theta is equal to cos of minus theta, while minus 1 into sine theta is equal to sine of minus theta. Okay, so that's your important conclusion. And along with this, what else can we conclude? You can also tell that tan of minus theta, which is equal to sine of minus theta by cos of minus theta, So which is in turn equal to -1 into sine of theta, and this is cos of theta, right? So this is basically -1 into tan of theta. So tan of minus theta is yes, right? So these are your following observations. Okay, so yeah, let me summarize whatever we did now. First thing, we saw that the nature of sine, cos and tan in different quadrant. I ended up with summarizing it as all students take coffee. So in second quadrant, sine and cosec are positive. Third quadrant, tan and cot are positive. In fourth quadrant, cos and sec are positive. Okay, next, when it comes to odd multiples of and even multiples of 90s, when it comes to different trigonometric functions, all we have to do is take complementary angles. So the conclusion is take complementary trigonometric ratio. Okay, so I gave a lot of example, I don't want to discuss that. And depending on the quadrant, right, so we have to go step by step. Depending on the quadrant, we define it to be either positive or negative. Okay, and last is negative angles. So cos of minus theta is same as cos theta. Sine of minus theta is -1 into sine theta, and tan of minus theta is -1 into tan theta. Right guys? And now you guys have to copy everything, don't miss anything.